Hi, everyone, and thank you for tuning into this webinar. I go by JC, and I'm Chief Architect for Informix. For those who don't know me, I began working for Informix in 1991, a magical time when dinosaurs roamed the earth. Um, I was I was hired into frontline support, not as a programmer. So when I later moved into development, I'd come by way of all levels of support. Obviously, my job now is to focus on innovation, but I like to think that after spending a good part of the mid 90s wearing a beeper on my hip, resurrecting down systems all manner of day and night, I really do care about software quality as much as I care about innovation. A major innovation Informix made back then was extensibility. Of the big four databases, Informix, Oracle, DB2, and Sybase, Microsoft wasn't the player it became in a couple of years later. But of those four, IDS was really the first to allow an outside developer to create their own data types and their own C code or Java code to run inside the server as a first-class citizen. We called each related bundle of user-defined types and user-defined routines a data blade. And lots of developers went to town with this feature. We did too. We wrote a handful of our own data blades that are still available and popular 30 years later. When you download IDS in 2026, you get bundled with it a basic text search blade, a geospatial blade, and a time series blade. Now, early this year, we set out to make IDS a great place to natively store and use vectors, which is a complex data type that isn't technically new, but its criticality to the world is fairly new. And right away, we realized that the best way for us to do that was by leveraging our own extensibility technology. So 5 months later, here we are. We've done that. And today we are unveiling the HCL Informix VectorBlade. Now, right out the gate, I'll mention that this blade does not work with an IBM Informix backend. It only runs with HCL Informix. And it is not supported on any server version lower than 15.0.1. I'll tell you the exact minimum version we recommend a bit later. Meanwhile, we've got a team that is keen to introduce it to you, so we'll get started. We have data strategist, IBM champion, and longtime Informix champion, Jean-Georges Perrin, who goes by JGP, to talk about what vectors are and why they are so useful in artificial intelligence applications. Then I'll swoop in and talk about the power that our blade gives you over this new world. And we'll have a demo by Informix field engineer and all-around excellent guy, Scott Norris. Now, while all this is going on, feel free to ask questions and the team will do our best to field them live. Just use Zoom's Q&A feature and window rather than the chat, if you would, because that's where we'll be looking for them. So thanks again for joining us, and JGP, please take it away.
All right, hi everybody. Um, for I've been in the Informix world for a little bit as well. Okay, so not as long as JC, and probably not as in a prominent way as JC, but I started my journey with Informix back in 1997 with a company called 4J's Development Tools, and it started, what something I like to say about Informix is that before that I only had, kind of college level knowledge of databases, and I really hated them. And karma hit, and and it stuck to me. So I joined when I joined Actian a year ago, almost to the date. It's been really an interesting moment to be back in this fantastic Informix family, and I'm really happy to see that this webinar is pretty well attended for 1 a.m. in Sydney. Okay, so why do we do vector? Okay, so the whole idea is that vectors are what is driving similarity. And this is the best way we've actually find to do that, at least for now, when it comes to comparing different things. Okay, comparing text. So like a puppy is a dog, or and this is a kind of similarity we need to do to understand better the prompts and the questions and the semantic approach to doing AI. So there is actually two ways to do it. Uh, the algorithms themselves, as we're going to see, are not new. What is it's and it's always the same thing. Like big data allowed to do more analysis. Now we've got the compute power to actually do AI like we were always dreaming to do. Okay, so there's really two ways of doing that. The current way, with the popular way, is to actually do it in another database, to install some kind of a vector database you would download, you would install, you would manage separately. It's a stand up. It's You've got to build and maintain pipelines, and we all know that pipelines are brittle by nature. You've got duplicate data. You've got to have to learn a new system and a new security model for those databases. And of course, you've got to there's part of the life cycle of all of that. You've got to do backups, and of course, you've got to provision the infrastructure. Whereas, so this is how people are doing it right now. Or you trust what you have, and if you're using Informix now, it's probably because you already trust it for a long time, and you can just do all this exact same operations as you were using them as you're using the engine. Okay, that's a benefit of what JC was just saying about this opaque types that are really part of our strategy. That when Next slide. So, and we all know, okay, we all know that AI is the is difficult. That the ROI around AI is not easy to find. We also, when ChatGPT started, the magic of I am asking a question and I'm getting a good answer. I'm asking Claude Code to generate some code, and I'm getting good applications. But when it comes to the enterprise data, to the enterprise knowledge, it's actually very difficult to get something. Okay. And those figures are kind of scary. Okay. You see that MIT saying that Gen AI delivers no ROI, 95% of them. You see that McKinsey said that um, deploying agent is very difficult. You see that Gartner is saying that 40% of the program will be abandoned. Okay, so there's really a lot of threat around this thing. So the challenge is there, do you really want to um, adding a new database or a new database strategy on top of that? So that's really the kind of questions you can ask yourself. Okay, and and if we look at the iceberg, and the iceberg we've all been seeing, so like 20% of the data is structured, and that's an estimate that has been floating from Gartner for a long time, and the 80% of the unstructured data. Okay. So there was always a myth that we could be able to transform the unstructured data into structured data, but this is not happening. Okay. And the thing is that nobody's doing it. So one way to do it is to actually put all those unstructured elements, all this unstructured text, image, etc., into into a database where you can actually seamlessly kind of ask to dig into like you would do your normal SQL. Okay, so that's one of the value of that as well. So and you know, like as JC was saying, you know, the blade technology that has been at the heart of Informix, and the design of the architecture have allowed to support a lot of different models. Okay. Um, I remember a lot of efforts around time series that and that made Informix a very popular choice in the telco industry, or even Informix being one of the first engines to support natively XML. So that was, you know, when XML was popular. I still like XML. So all of that really meant that, you know, it's not you're not choosing a database based on the current trend of something. Okay, like, we're doing vector, so let's have a new database for vector. Oh, we're doing relational, let's have a new database for relational. Okay, so we're really being able to capitalize on the existing assets, on the existing data without movement, etc. So that's really why now you can have this new eighth data model in this architecture, this Informix architecture. And you see it, okay, when you compare it to different products. Okay, here I just compared to four popular databases. So you've got ours, you know, our beloved Informix, and then you see the other guys. Okay, so it's always we always thrived by doing the technical and the technology things correctly because of the architecture that was there. Okay, so for example, when you're talking about replication is almost coming out of the box, whatever the type is, and it makes a difference. So yeah, some are open source, some are free, but you still have. It's not only about the license cost here it's coming, it's also coming about the cognitive load to understand how those new products are actually working. So, and really, when you think of it, it's not a new game for Informix. I mean, we started, and I remember playing with Excalibur back in the day. It was probably a little like a lot of things with Informix ahead of its time, and a little bit before we had the real use cases and the very popular use cases. So now with this new ways of indexing, and we've managed to actually come to be a very competitive vector a vector architecture for your data needs. Okay, so I think we've achieved that. It's pretty impressive, and I'm kind of looking forward to a little bit knowing with you, sharing with you, and understanding a little bit more about the technical details that JC is going to go through, and the demo that Scott is going to do just right after. So JC, back to you.
Okay. So as I said earlier, extensibility is something Informix does really well. And to be honest, adding a native vector data type to IDS took about a day. It's simply an opaque UDT of variable size, depending upon how many dimensions your vector has. And it's stored internally, kind of as you expect. It's an array of 4-byte floats preceded by a number of dimensions. We've sized it so that currently the maximum number of dimensions is 1536, which coincides with OpenAI's text embedding 3 small vector format. But if there's demand for larger vectors, we can easily upgrade the type, which by the way is called lvector_embedding. I'm very curious to see how people use this blade and what they decide is missing. We have some very creative, clever customers, so I have no doubt we'll have some interesting improvements to make over the next 6 months. Anyway, um, creating that lvector_embedding UDT and a handful of supporting functions. You need two casting routines that will convert from an LVAR to a vector and back. You need input-output routines, network send and receive. That part was relatively easy. I don't know if it took a day, but it was probably close to a day. It's indexing vectors with thousands of dimensions and searching on them efficiently that's a little more involved. So rather than reinvent the wheel, we decided to use an open source library for a lot of this heavy lifting. Google has one, there's one from Microsoft, but in the end, we went with LanceDB. Now, LanceDB does exist as its own standalone database product, but this is not that. Um, they also have a C library that supports a large subset of the standalone product's functionality, and that is what we incorporated into the Blade. This library is already quite mature and offers a variety of index types such as IVF flat and an interesting combination of IVF and HNSW. And of course, the three main distance calculation methods, which are Euclidean, cosine, and dot product. So we combined the LanceDB library with an interface layer of our own consisting of about 30 UDRs into one shared library called lvector.bld. Like all blades, this guy gets installed beneath the Informix extend directory. Now, once the blade is installed, as long as you're running HCL Informix version 15.0.1.10 or higher, it will auto-register. You can use it with .9, maybe even before that, but it won't auto-register as nicely in those earlier versions of 15.01. And what that means is that when your application calls one of those 30 UDRs for the first time for a particular database, the engine automatically does a couple things. First, it runs this objects.sql script, which is part of the blade, and the definitions for those UDRs and the L-vector embedding UDT are added to the system catalogs. Then if you don't already have an LVec class VP running, one will be spawned automatically. Obviously, we recommend that you add a line to your config file, a VP class line that includes an LVec class of some number of VPs that you want running. But initially, you probably won't have one, and so we'll automatically spawn one for you. And then the LVector shared library is loaded and dynamically linked into the LVec VPs. At that point, your blade is active and ready to go. So what can you do with it? Well, here's one possible scenario. You can create an Informix table that has a column of type L-vector_embedding, for example. This table will also have a serial or a big serial column that will uniquely identify each vector. That's pretty important. And then it has an LVarchar column called metadata. The column actually has to be called metadata that can store any text, but usually you'd put categories in there or keywords that you might want to filter on. Beyond that, the table might have columns that contain whatever object was embedded, like an LVarchar column for a chunk of text or a blob column or something along those lines. This is just a simple example. So you can load thousands or millions of vectors into that table, identifying each vector using the serial column. You can then index and search on those vectors for the nearest neighbors by creating a columnar Lance table and flash synchronizing it with your Informix table. This will very quickly copy all the vectors and the IDs and the metadata into the Lance table, which can then be indexed and searched. You can search the Lance table by itself. Sorry, Nick, we want to go back. We're not at the next slide. Sorry. Go back a little bit more. One more. Okay. So next slide, please. Here's where we are. This is where we are. So you can search on the Lance table by itself, or you can, of course, join that table with the traditional Informix table or any number of Informix tables to retrieve, say, X nearest neighbors to a given vector, plus whatever text or image or other object is associated with those neighbors. You can do hybrid queries. In fact, you can do them at multiple levels. For example, the Lance table will store the metadata along with the vectors, as I said, and this metadata can itself be indexed and filtered on. You can also filter on one or more columns in your Informix table if you're performing a join. The purpose of this would be to get the 10 nearest neighbors to a vector based on both semantics and some keywords, for example, but then to call that list of neighbors by filtering on whatever you like from the Informix table or tables. This honing using hybrid queries can significantly reduce AI hallucinations, which we know is an issue. And it's dead simple with this VectorBlade. So where do you get all these vectors? In what part of your application does the embedding happen? Well, it's up to you. You can bring your own embeddings, and IDS will happily index, search, and store them along with any associated objects like images, sound, text, whatever, the way it has traditionally done that. But as a convenience, we've also included in the blade a UDR called lvector_embed, which will take an lvarchar as an argument and go out to OpenAI, embed that string, and return a vector with 1,536 dimensions. The only prereq is that you have an OpenAI API key and provide that key to IDS with a new configuration parameter. Next slide, please. So here's an illustrated example of one specific RAG use case for the blade. Your organization has a bunch of proprietary documents. They could be technical specs, internal policy docs, anything that's important to you or your organization that you don't want out on the wider web. You feed those documents into an application that chunks the text, meaning a trained model breaks up the document into overlapping sections. Each chunk is then embedded by a model of your choosing, and you use the VectorBlade to store and index the resulting vectors along with their chunks in IDS. Next slide, please. Now it's time to search on those vectors. So let's say a user types a natural language prompt into your app, which embeds the prompt using the same model. You pass that resulting vector to IDS and ask for, say, the 10 nearest neighbors. You don't want vectors back. What you want is vector IDs, which you can then use to find the associated chunks in an Informix table. You then pass those chunks of text to an LLM, which formats the answer, which is displayed for the user, that kind of thing. Next slide, please. Now, the great thing about this blade, which JGP touched on, is that it's just one fully integrated slice of the IDS pie. All the action I've described here could be happening in one corner of your production database without dragging the performance of any other production tasks. You don't need a separate database. All your relational data can join in on the fun, and everyone gets along. Next slide, please. So here's what you can do to get started. Presumably you have HCL Informix 15.0.1.10 or higher already installed and running. And you've downloaded the Blade tar file. It's really just a tar file that you install into Informix.extend. You configure a few things, such as your OpenAI API key if you're going to create embeddings using the Blade. You then register the Blade for your database, and off you go. You can manually register the Blade, or you can let it auto-register, as I mentioned before. In the Informix.extend directory, you'll find a subdirectory called samples, and in there we've provided some sample SQL scripts that you can review and execute even. And at that point, you could start experimenting with the 30 or so UDRs using DB Access. And from there, you can begin writing your application. Next slide, please. So this is a more involved workflow diagram that brings up several additional points. Before you bring your application online, you've probably ingested a bunch of data that's depicted, that phase is sort of depicted at the bottom there. You've created vectors for text and images and loaded those embeddings along with their associated objects into Informix using the Blade. You then index the vectors. Now, when you create an index on a Lance table containing vectors, that doesn't render the table static. You can insert and delete vectors just fine, and your searches will still make use of the index. So after the ingestion phase, You start your application, and a shopper searches for a product using a natural language description rather than a specific product name. Show me your least expensive mountain bikes that have disc brakes, for example. That prompt is embedded by your chosen model. The resulting vector is then used in an ANN query against Informix, which returns the IDs for however many nearest neighbors your application requested. Those IDs are used to join to find the most relevant items in your catalog, and then the list is ordered by cost. In theory, all that can be done in one hybrid query. The results are then sent back to the user, or you could also use an LLM to format and augment the results before displaying them. That's pretty much what we have. And now Scott is ready to show you a demo that kind of models the same thing. Take it away, Scott.
Hello, and welcome to the demo portion of Modernizing with HCL Informix, bringing your AI to your existing data with VectorBlade. My name is Scott Norris, and I'll be running through this demo with you. First, we're going to recap what we need. First, you'll need HCL Informix 1501.10 or later. This does not run on IBM Informix. We are running this on a Linux Red Hat 8.8 or higher VM. You also need an open API key that you need for embedding generation. We need about 2 gigabytes of space. And then finally, the archive. First, we want to go into our Informix stir extend directory where all the blades are located. And we're going to untar the new HCL Informix VectorBlade. We're going to add the following 3 export commands into our shell. And then in our onconfig file, we are going to add these 3 commands into our onconfig configuration file. We're then going to register the engine with the VectorBlade. We're going to create the table, knowing we're using a new data type, the L vector embedding. And then we're going to execute a create an L vector Lance table in our database. Now, be good to note that this Lance table sits outside of your Informix database, and it's a separate directory. We're going to insert into the product table, again, using some of the new UDRs that are available with this new VectorBlade. And then we're going to sync the VectorBlade with the Lance table. Finally, we're going to ask it to find something for us within the VectorBlade. So let's get started. Let's set this up. And first, we're going to kind of run through this example, and then we'll expand upon that about what you can do with the VectorBlade. So, as you can see, I'm in my DB Access panel, and I'm just going to go ahead and create a database called examples. Now I'm going to register my blade with my database. So I like to make sure that I'm in the particular database. So we'll go ahead and select that examples. And then we'll register the blade here. We run the registration command, and now it is registered. Now let's create a couple tables. First, we'll create our product table. And then we'll create our Lance vector table. Now that we have our tables set up, both our vector table and our regular Informix table, we're going to insert some information into those tables. So we have one row inserted. Now we're going to sync our database table with our Lance table. Now that we have that sync done, now we're going to do a search on our tables. And based upon our search, we have found that the wireless noise canceling headphones with what their distance is from our particular search. Okay. So we've gone through creating, registering, creating tables, creating a vector Lance table, adding some information, and then syncing that information with our Lance table, and then querying that some information back. Well, that's great. And I'll also point out there's several samples that are associated with this VectorBlade. But what else can you do with this? Well, let's show you. So now I'm going to bring up another window. And one of our engineers had built out a little application. This is a containered application, has a Informix database in it. It has all the parameters for setting up and configured with the VectorBlade. And it has a front end GUI. So first we're going to start our Docker image here and execute that. Yes. So we've started up our Docker image. And we'll take a look and make sure it's fully operational before we pop into our next step. Okay, our Docker image has finished booting up, and it has pushed out our GUI onto the web. So we'll take a look at that. And this is our GUI that we have associated with our Docker image. So again, we have Informix, we have the VectorBlade, and we have this little application that was built on top of that. All right, so now let's do something. So let's take a look at the local favorite football team here in the Carolinas, the Carolina Panthers. Okay, so we're going to pulled in from a PDF, pulled in the Wikipedia page for the Carolina Panthers. Gives us all the information about the Carolina Panthers, everything you wanted to know but didn't want to ask. So we're going to load this up into our VectorBlade, maybe ask it a couple questions. So here we go. We're going to upload the file. Now we're going to start our process. We're creating our vectorized segments, and we've finished processing and embedding this PDF into our application. Well, what can we do with this now? Well, we can take a look. We have this right here. And just to give you an overview, what's happening is we'll have a user, single or multiple documents. We're loading the document, splitting it into chunks, generating the embedding, storing in the vector DB, and now we're going to have a little conversation with that document. So first we'll do a semantic search, which is I'm just looking at the document itself for anything that I've uploaded into my vector and ask it some questions. So what is the mascot of the Panthers? And by doing a semantic search, it's kind of going through and saying, okay, well, based upon the encoding of that question, here's the nearest possibilities that it might fit. All right. Well, let's add in the OpenAI, make it look a little bit nicer. So let's do that again. What is the Panthers' mascot? So we went out to our document, went out to OpenAI, but it pulled in the mascot of the Carolina Panthers is Sir Purr. Great. So you remember this is only one document about the Carolina Panthers, but let's say I have interest in, what is another NFL team? I know the city, but don't know what they are. So let's ask AI on that. What is the football team in KC? And again, it's not in the PDF that I loaded, but it went out to OpenAI and said, okay, well, I can supplement that. I embedded your question and I found this. Football team in Kansas City is the Kansas City Chiefs. Great. So here's where we've demonstrated I can load documents and do a semantic search. That would be everything I have loaded up in the database that is important to me or my knowledge base. I can go outside of my vector database and do an AI search using OpenAI to either pretty it up or get additional commentary from OpenAI. That concludes our demonstration for today. Thank you very much.
Let's go to some Q&A. I've got some questions here that Scott and I just Scott and I will answer. I see that there's something from John. Yeah, we've got a couple from the actual Q&A window. I'm going to get back to those in a sec. So, Scott, can you say how much the VectorBlade costs? That's probably an obvious question people will ask.
Right. So the VectorBlade is free with Informix 15. So there is no cost associated with that.
Okay. And another question is which version of Informix supports the VectorBlade? I've already kind of gone over this. It has to be HCL Informix and it has to be 1501. Now we recommend 1501.10 or higher because it's in that version that we programmed auto registration. You can manually register the blade with an earlier version, but it's just a lot nicer to use the one that does the auto registration. It's not available on older, it won't work with older versions like 1410 or 1210. And so if you're on an older version, that might be a compelling reason to upgrade. So next question, does IBM have Informix? Does IBM Informix have this? That one's for you, Scott.
Yes. So IBM Informix does not have the vector blade, nor will we allow it to be used within IBM Informix.
Okay. Is there an easy tutorial for me to test out the VectorBlade capabilities? Yes, as I said, when you install the blade, you untar this file into Informix store extend, and there's a subdirectory under there called samples. And that does have 4 sample scripts that do work, I promise. And they're of increasing complexity and interest. So the first one just registers the blade and does something very rudimentary. By the time you get to number 4, you're using triggers to insert rows into your Informix table and automatically sync them with your Lance table, and it's more interesting. So
Correct. Yeah,
next,
and
go
just
ahead.
a word on that is, yeah, they all do work because I ran them this morning and last night, and all those were working for me prior to the session here.
Yeah, that's life, I guess. So Scott, for you, how do I get an evaluation license?
Right. So, and you may want to post this in the chat, Nick, but we do have a email address that you can reach out to us to get an evaluation license, and that will come to the product manager, Emily Taylor, and myself, and we will contact you and get the ball rolling on that.
Okay, I'm answering some questions here. We got John asked, is there an HCL equivalent to IBM Informix Developer Edition? So we have these editions on the IBM side. We don't tend to have the same kind of setup on the HCL side.
The question is on that. No, we don't. We're always the HCL Informix version is the Advanced Enterprise version, comparable to IBM. But HCL only supports and sells that one version.
Okay. Colin asks, will the open source dependencies impact ISVs and OEMs that may sell solutions based on the VectorBlade? This is, I'm afraid, out of my pay grade. Obviously, LanceDB, the C library that we're using is an open source library, and we have an Apache license for that, a normal Apache license for that open source library. Scott, or anyone else among the panelists, do you know whether this has an effect on reselling? I do not.
I do not. I do not.
We'll
We
have to
can
get
take
back to
that.
Colin.
We can take that and kind of do some follow up.
I sure hope not. But we'll look into that.
We support the product. Okay, so whether we're not going to outsource the support of that if it's part of the product, right?
Correct. Yeah.
Yeah. Okay, I don't see any other questions coming in. So, oh, we got another one from John. How do you expect to get new HCL Informix clients without a developer edition, specifically focusing on the VectorBlade, which would seem a big differentiator? I am going to
Well,
leave
I
that
can
for
I can
Scott.
yes, I can take that. So yeah, we realize that when we do since we only sell the one version, um, and every user is different, but we've been very competitive in making sure that we can get you that product. So that's a discussion that I would be happy to help you with and kind of understand the nuances in your environments. But as I've been told several times by my management team, don't let cost prohibit you from making a deal. So,
And as Kevin
That,
pointed
that's a
out,
serious promise, Scott. Okay.
yeah, yeah. Well, you don't know how much the juggling I do in the background to make everything happen here.
so Emily has said, John Ritson, it's possible for any interested user to obtain a free trial license for a limited time. But what you get to trial is the HCL Informix Enterprise Edition. So that's kind of cool,
Hmm.
but it's a limited time.
Correct.
Did you try this data blade in native language? Oh, so maybe non-English is the question? That's a really good question. Actually, JGP asked me that question, and I meant to try a French prompt, but I never got around to it. I have not tried that. It depends on, we're using the OpenAI LLM, and their embedding model, and I'm guessing it's not English only, but I have not tried that. It's a really good question. I'll have to give that a shot. Okay.
When I read the question from Boyko there, I was thinking about when he said native language, I was thinking about Informix 4GL.
Yeah.
So I would expect that it works with 4GL. So
So JGP, you haven't tried um, OpenAI embedding model or LLM with French, have you?
no, I have not, and I can't wait to try the blade itself, but I've been a little bit too much on the road
Yeah.
lately to do that, but it's very high on my bucket list there.
So Boyko, I hope I'm pronouncing your name right. Boyko has mentioned that he wants Bulgarian. That's going even further. I I wouldn't know how to test that, but there's a chance it'll work. As we find out when we use these AI tools, that they do things that we don't expect them to do sometimes. They do them better than we expect. So we'll have to give lots of different languages a shot. So seems like the questions have wound down here a little bit, and obviously we have a few glitches to work out with our demo, but hopefully you get an idea of what the blade does, and you're interested in trying it out, and that you've enjoyed our webinar. I guess we can close the webinar now. Thanks everyone for coming along.